Hello students, hello and welcome to this video on permutation and combination. In this video we will solve question number 251 to 260, and the link to download the PDF will be in description. As well, I will show that how you can download the PDF at the end of video. So without further ado, let's get started. Question 251 says that show that there cannot exist two positive integers n and r for which NCR, NCR plus 1, NCR plus 2 are in GP. Very straightforward question. So for the given numbers to be in GP, we assume that these three are in GP. So from GP we know that the ratio of terms will be equal to common ratio. So we write NCR by NCR plus 1 is equal to NCR plus 1 by NCR plus 2. Now it is a mere matter of expansion. NCR becomes n factorial by r factorial multiplied by n minus r factorial. NCR plus 1 in the denominator becomes r plus 1 factorial multiplied by n minus r minus 1 factorial by n factorial. Now n factorial will cancel n factorial, r factorial will cancel r plus 1 factorial, and remainder quotient would be r plus 1, which is written here. And n minus r minus 1 factorial will cancel and n minus r will remain, which will be in denominator over here. Right hand side would be n factorial by r plus 1 factorial multiplied by n minus r minus 1 factorial, which is NCR plus 1, and NCR plus 2 in denominator will become n factorial here, and r plus 2 factorial multiplied by n minus r minus 2 factorial. So again n factorial will cancel each other, r plus 1 factorial will leave a quotient r plus 2 when dividing r plus 2 factorial. Similarly, n minus r minus 2 factorial will cancel the terms till n minus r minus 2 factorial in n minus r minus 1 factorial, and that means we will have a quotient of n minus r minus 1. Now we have this equation, that is r plus 1 by n minus r is equal to r plus 2 by n minus r minus 1. So we cross multiply, we get nr plus n minus r square minus r minus 1 is equal to nr plus 2n minus r square minus 2r. Now nr will cancel nr, n will be subtracted from 2n, which will leave n, r square will be cancelled, 2r will be cancelled, and minus 1 will remain. So n will become minus 1, which is not possible because n has to be a positive number for the combinations to exist. And that means that our assumption that the three numbers are in GP was wrong, and therefore these three cannot be in GP. Question 252 says that show that there cannot exist two positive numbers n and r for which NCR, NCR plus 1, NCR plus 2, NCR plus 3 are in arithmetic progression. So again, like previous problem, we assume that the given set of numbers exist in arithmetic progression. The common difference will be equal. So NCR plus 1 minus NCR is equal to NCR plus 2 minus NCR plus 1 is equal to NCR plus 3 minus NCR plus 2. And then we write the expansion of all these, which is written here. And we take the first two, that is NCR plus 1 minus NCR as well as NCR plus 2 minus NCR plus 1. So from first two, that is NCR plus 1 minus NCR, we take n factorial by r factorial multiplied by n minus r minus 1 factorial common. That is, from here we take these common. So what will remain inside the brackets is 1 by r plus 1 from this one and nr from this. So we take LCM, and this should be 1. No, sorry. This right hand side here comes from this, that is these two. So from these two we take n factorial common, r plus 1 factorial common, and n minus r minus 2 factorial common. So within the brackets we will have 1 by r plus 2 minus 1 by n minus r minus 1. So from these two you see that we can cancel n factorial, we can cancel r factorial, and we can cancel n minus r minus 2 factorial. So n minus r minus 1 will remain here and r plus 1 will remain here. For the terms inside bracket we take LCM. So we have this expression which is 1 by n minus r minus 1. Upon taking LCM of these two terms we have n minus 2r minus 1 by r plus 1 into n minus r. and from these two we have r plus 1 divided by multiplied by 1 n minus 2 r minus 3 by r plus 2 into n minus r minus 1. So eventually we end up at the equation n square minus 2nr minus 3n minus nr plus 2r square plus 3r. So similarly we can have another equation by combining these two, that is the last two. So that will give another equation which will be in n and r, and when you will solve those equations you will see that n and r do not have integral solutions. So either they will be non-integral or they will be negative. So you won't have integral positive solution for n and r. So that is left as an exercise to you. If you have problems doing this second part, let me know and I will add this in the solution of 252, and you can follow that. I think in the PDF I'll actually add that rather than leaving it. So give me time and I will add the full solution of this. Till then you can try solving it. Question 253 says that show that for all positive integers, show that 2 into 6 into 10 multiplied up to 4n minus 6, 4n minus 2. So you see, this is arithmetic progression with common difference 4 is equal to n plus 1 into n plus 2 and so on up to 2n. This is also arithmetic progression with common difference 1 and starting from n plus 1. So we are given this. What we do is from the left hand side we take 2 common from each term. So there are n terms starting from 2 to 4n minus 2. We take 2 to the power n common, 2 from each term. We are left with 1, 3, 5 up to 2n minus 1, which is equal to 2 to the power n multiplied by 1, 2, 3, 4, 5 up to 2n. Essentially we multiply with 2n. And what we do is we also multiply with 2, 3, 4. My mistake. So from this term we multiply 2, 4, 6, 8 and all the even terms. There should be 2n minus 2 here and then 2n. So we divide also from 2, 4, 6 up to 2n. So when you do that, the equation in the numerator, the bracket is missing here. The equation, the amount in denominator, if you look at 2, 4, 6, we take 2 to the power n common again and it will remain 1, 2, 3 up to n. Now 2 to the power n will cancel. The numerator will become 2n factorial and denominator will become n factorial, which is essentially n plus 2 into n plus 1 into n plus 2 up to 2n, which is our right hand side. Question 254 says that show that 47C4 plus sigma I is equal to 0 to 3, 50 minus IC3 plus sigma j is equal to 1 to 5, 56 minus jc, 53 minus j is equal to 57C4. So it's a very easy solution. First we consider the expression on left hand side and we substitute I is equal to 0 in the second term. So it will become, we put I is equal to 3 in the second term. So it becomes 50 minus I, that is 50 minus 3, so 47C3, which is written here. And the range will become I is equal to 0 to 2. Now 47C3 and 47C4, when it will be added, it will become 48C4. Now in the second term, we put I is equal to 2 and take it out. So it will become 48C3 and the range will become 0 to 1. So it will become 49C4 now. Okay. And then we put I is equal to 1. It will lead up to 50C4. And then we put 0 again. We will get 51C4. And then we will have the third term, which is now second term in the expression. J is equal to 1 to 5. So we first put J is equal to 5. We get 51C48. Adding these two will give us 52. This is 51C48, which is equivalent to 51C3 because NCR is equal to NCN minus R. So this will become 51C3. Now adding this, it will become 52C4. Then you put J is equal to 4. It will become 52C49. So 52C49 is 52C3. So you add that with 52C4 from these two terms and you repeat, and eventually you will end up with 57C4. Question 255 says that show that nck plus sigma j is equal to 0 to n plus j ck minus 1 is equal to n plus m plus 1 ck. So just like previous problem, we first substitute j is equal to 0 in the second term. It becomes nck minus 1 and our range becomes 1 to m, and the term inside the sigma will remain same. So nck plus nck minus 1 will become n plus 1 ck, and then we put j is equal to 1. So we get the term c n plus 1 k minus 1 out, and range will now 2 to m. So you repeat this and go on increasing the value of j, adding with the terms obtained, and you will eventually end up with n plus m ck plus n plus m ck minus 1, which will be n plus m plus 1 ck, which is our right hand side. Question 256 says that show that mc1 plus m plus 1 c2 plus so on up to m plus n minus 1 cn is equal to nc1 plus n plus 1 c2 and so on up to n plus m minus 1 cm. So what we do here, on the left hand side we add 1 is equal to mc0. So we have mc0 here and we add it with mc1. So it will become m plus 1 c1, and then we add that with m plus 1 c2. It will become m plus 2 c2. We add this with this, so it will become m plus 3 c2. So you see, it will become m plus. Let me it come back. mc0 and mc1 will become m plus 1 c1. M plus 1 c1 and m plus 1 c2 will become m plus 2 c2. M plus 2 c2 when added with m plus 2 c3 will become m plus 3 c4 and so on. So at the end it will be your m plus n minus 1 c1, and before that will be m plus n minus 1 c n minus 1. So you can add that. Now did I make a mistake? I don't know. Let's repeat this. mc0 plus mc1 will become m plus 1 c1, and that will become m plus 2 c2 when added with this, and that will become m plus 3 c3 and so on. Similarly, on the right hand side what we can do is we can add nc0 here, okay, and you go on repeating. So in the end what will happen is your left hand side will become m plus n cn and right hand side will become m plus n cm. So these two are equal because ncr is equal to nc n minus r. So it can be written as right hand side m plus n c m plus n minus m, that is n. So it is quite simple solution, just that you have to take care of the fact that you are adding 1 to both sides, but that 1 is different. It is mc0 on left hand side and mc0 on right hand side. It is just a repetition of this formula, that is ncr plus 1 is equal to n plus 1 cr plus 1. Now we move on to question 257. It says that how many numbers of 5 digits divisible by 25 can be made with the digits 0, 1, 2, 3, 4, 5, 6 and 7. So for the number to be divisible by 25, the last two digits have to be 25, 50 and 75, or double zero. Double zero we have ignored because there are no two zeros, okay, and yeah. So case 1 is when last two digits are 25 or 75. In this case, thousands place can be filled in 5 ways, 10,000s place can be filled in 5 ways, thousands place can be filled in 5 ways, and so on. So total number of numbers would be 2 multiplied by 5 multiplied by 5 multiplied by 4, that is 200. The second case is when the last two digits are 50, then 10,000 place can be filled in 6 ways and so on. The total number of numbers is 654. So see why we are having only 654 and here 554 is we fill 10,000 place, 1000 place and 100 place. Tens and units place are filled in both the cases by 25, 75 and 50. So this 6 into 5 into 4 is 120. Thus total number of numbers divisible by 25 is 320. Question 258 says that how many numbers of 5 digits divisible by 4 can be made with the digits 1, 2, 3, 4 and 5. So a number is divisible by 4 if last two digits are divisible by 4. That is, last two digits in our case could be 12, 24, 32 and 52. So we fix last two digits, then 10,000th place can be filled in 3 ways, 1000th place can be filled in 2 ways, and 100th place can be filled in 1 way. The total number of numbers is 4 multiplied by 3 multiplied by 2, that is 24. Question 259 says that how many number of 4 digits divisible by 3 can be made with the digits 0, 1, 2, 3, 4 and 5. Digits being unrepeated in the same number. How many of these will be divisible by 6? So we know that for number to be divisible by the 3, the sum of digits must be divisible by 3. We will have two cases. First case is when the number contains 0 and when the number does not contain 0. So if the number does not contain 0, or rather this is a number when the number contains 0, right? That is our first case. So this can be a combination of 1, 2, 3, 1, 3, 5, 2, 3, 4, 3, 4, 5. The thousandth place can be filled in 3 ways. Okay. So 1, 2, 3, 2, 3. Give me a moment. 5 digits. We take 0. So 0 is present, and then one of these digits can be used. So if you take 1, 2, 3, then 4 and 5 cannot be used. Okay. Now 4 and 5 cannot be used, and we have 3 digits. So along with 0, there are 4 numbers, but 0 can't be at 10,000. 0 can't be at thousandth place. So thousandth place can be filled by one of these numbers. Okay, these are 3 numbers. So 3 and hundredth place in 3 and tenth place in 2 ways. So total number of numbers is 4 multiplied by 3 multiplied by 3 multiplied by 2. That is 72. We multiplied with 4 because there are 4 such combinations. Now you see thousandth place can be filled in 3 ways. That is one of these numbers, and hundredth place can also be filled in 3 ways because 2 of these remaining numbers and 0. So that is why this 3 is there. Now the second case is when 0 is not there. So 4 digits would be 1, 2, 4, 5. You can't have 3 in here. So you can have 4 factorial, that is 24 combination. Total number of such numbers is 96. For the number to be divisible by 6, the sum of digits must be divisible by 3 and last digit must be even. So you proceed similarly and you will obtain 52 as number of numbers which are divisible by 3. So this part is left as an exercise. Question 260 says that find the sum of all 4 digit numbers formed with the digits 1, 3, 3 and 0. So let's assume that 2 3s are different, then thousands and hundreds place can be filled in 3 ways, tenths place can be filled in 2 ways, and units place can be filled in 1 way. So total number of numbers is 18. However, 3s are same, so number of numbers is 18 by 2, that is 9. Out of 9 numbers at units, tenths and hundreds place, 3 will come 4 times, 1 will come twice and 0 will come thrice. On thousands place, 3 will come 6 times and 1 will come thrice. The sum of digits at units place is 4 multiplied by 3 plus 2 multiplied by 11, 14. That will be also true for tens and hundreds place. That is, sum of digits would be 14. But sum of digits at thousandth place will be 6 multiplied by 3 plus 3 multiplied by 1, that is 21. So sum of numbers would be 22,554. With this, we come to the end of 26th set of problems on permutation and combination, and I hope that you are finding this playlist useful, the entire playlist of algebra. And if you have any confusion about any of the answers, or if you have any other questions from any other book on class 12 algebra, please do ask in the comment box and I'll try my best to help you, but there's no guarantees. So now I'll show you how you can download the book. Okay, so you can go to my website ashtavakra.org and you will see that There are 3 books: Algebra, Trigonometry, and Coordinate Geometry. You can download the PDFs here and study on your own. That is my tagline: self-study is ultimate penance. Now note that there is a piece of warning I want to give is that there could be a lot of typing mistakes in the book. So read with care. Okay. I have nobody to review the book, and there is no proofreading is done. There could be a lot of mistakes, typing mistakes or otherwise. So I am fixing those as soon as I find them, and so please take care when you study these PDFs. Now I will end this video here, and I thank you for watching the video. So we'll meet again tomorrow with 10 more problems, and till then keep practicing, and I will take my leave. So thank you again for watching the video. Enjoy.